Hello, welcome back to Mrs. Torres' YouTube channel. Today we're going to continue factoring. We've got some special cases today. So let's look at our first example. X squared minus 25. So this looks a little different than our other things that we've been factoring, right? We've usually been factoring trinomial, so that's with 3 terms. Today, most of the things we're going to factor are 2 terms, so notice there's no x term, right? Standard form is ax squared plus bx plus c. So there's no b term. So that means whatever our x values are, they canceled out, and we just have ax squared and c. So let's factor like we normally would. You can either guess and check, do your box method. So I'm just going to think of some factors of 25. Remember, we need them to multiply to 25. That's why we're looking for factors of 25. But what number do we need them to add to? Well, they need to add to 0, right? Because really, the b value is 0. This is really x squared plus 0x plus 25. But we don't write the 0x because that's silly. Sorry, minus 25. So we just have x squared minus 25. So 1 and 25. 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works, right? 5 times 5 gives us 25. All right. Well, right away, ding, 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 we have a winner. 5 and 5, same number, right? We just have to make one of them negative. So x squared minus 25 factors to x plus 5 and x minus 5. So now I want you to think about the relationship between x and x squared and the relationship between 5 and 25. Just think about that for a minute, and then we'll do our next example. So our next example is 16x squared minus 9. This time, our a value is not 1, right? So we got to slide and divide. Again, we don't have a middle value, but we can still slide and divide. So that's x squared minus 144. We need factors of 144 if you want to do the box method for this one. So we put x squared here, negative 144 there. All right, so we've got 1 and 144, 2 and 72. Does 3 work? Yep, 3 and 48. 4 and 36. 5 won't work. 6 and 24. 8 and 18. Remember, we need our middle values to cancel out. 9 and 16. And we can keep going. Eventually, we will get to 12 times 12, right? Well, ding, 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 we have a winner. Just like up here, how we had negative 5 and 5, we can do the same thing with 12. So we just have to make one of those negative. So negative 12x and 12x. So this will factor to x minus 12 and x plus 12. Remember, we were sliding and dividing here, so we've got to divide out our 16. This does not divide to a whole number, so we've got to reduce our fractions. X minus 3/4, x plus 3/4, and then send that 4 out in front of the x. 4x minus 3, 4x plus 3. There you go. So now, think about the relationship between 16 and 4, the relationship between x squared and x, and the relationship between 9 and 3. Hopefully you've realized that the square root of 16x squared gives you 4x. The square root of 9 gives you 3. So, these type of binomials are called difference of squares, or difference of perfect squares. because x squared and 25, those are both perfect squares. 16x squared and 9, those are both perfect squares. So you need to be able to recognize perfect squares, right? 4, 9, 16, 25, 36, 49. Also, you need to be able to recognize them with variables. So if we have x squared, x to the third, x to the fourth, x to the fifth, and x to the sixth. The way that you tell if they are perfect squares is if they have an even exponent, right? So x squared is a perfect square because the square root of x squared gives you x. X to the fourth, the square root of x to the fourth is x squared. And the square root of x to the sixth is x to the third. So you just cut that variable in half. So here's our difference of square rule. If we have a squared minus b squared, so that's saying you're subtracting two perfect squares. That's what difference means, right? You can factor that into a plus b and a minus b. So this is our rule. When you see a difference of squares, you don't have to do any work except figuring out the square roots of your terms. So here's our rule to remember. You will need to remember that rule. All right, so now let's use our rule to do an example. 36x squared minus 49y squared. So we see this, we notice, hey, 36 is a perfect square, x squared is a perfect square, 49y squared is a perfect square. So we know we're going to use our rule here. So we need to take the square root of both of our terms. So the square root of 36x squared. Well, if you don't know, you can do it in your calculator. Hopefully you just know, though. Square root of 36 gives you 6, right? So the square root of 36x squared is just 6x. The square root of 49y squared is going to be 7y. So you take the square root of the coefficient and then divide that exponent by 2. So then our rule says we just add our a and b and we subtract our a and b. So in this case, 6x is our a, 7y is our b. So it factors to 6x plus 7y and 6x minus 7y. And of course, we can FOIL to double check our work. So 6x times 6x gives us 36x squared. All right, we're on to the right track. We've got to make sure our middle terms cancel out. So 6x times negative 7y is negative 42xy. Oh, 7y times 6x is plus 42xy. And lastly, 7y times negative 7y, negative 47y, or 49y. And check those out. They cancel, so we're left with 6x squared minus 49y, which is squared. Forgot that part, sorry. And that's what we started with, right? So we know we are correct. We have one more special case. It's kind of a special case. Just how we write the answer is what makes it a special case here. So let's try this one. 9x squared plus 6x plus 1. We see our a is not 1, so we're going to slide and divide. X squared plus 6x plus 9. Think about my factors. Well, 3 and 3 will give me 9 when I multiply and 6 when I add. So x plus 3, x plus 3. We've got to divide out our a value. Well, those don't divide, so we've got to reduce our fractions. And then send our 3 out to the x. Now, normally we're done, right? But I want you to notice that these are the same binomial. So we could rewrite this as 3x plus 1 squared. So that's what makes this a special case, is when you factor it, you get the same binomial. So it's just that binomial squared. All right, see you in my next video.